You know, when we think about AI, we often picture these really simple yes or no decisions. But the reality is, it's a world of probabilities, confidence, and honestly calculated risks. So that brings up a huge question.
How does an AI actually decide if an email is spam or if a credit card transaction is fraud when it's stuck in that gray area of uncertainty? Well, that's the core question we are going to unpack right now.
Okay, so here's the first piece of the puzzle. It all begins not with a final answer, but with a score. The model doesn't just say yes or no. Instead, it generates a probability score, kind of like this 0.73 you see here. Now, this score is always going to be a number between 0.0 and 1.0. You can basically think of it as the model's confidence level. So a score of 0.99 means it's pretty darn sure, like 99% confident that something belongs to the positive class, like an email being spam. On the other hand, a score of 0.01 means it's not confident at all. A score is great and all, but we need an actual decision. So, how do we turn this number into a real classification? Well, we have to draw a line in the sand.
And that line is called the classification threshold. It's the rule we create to divide all those probability scores into two clean groups, a positive class and a negative class. It's literally our decision boundary.
The simplest, most common place to start is right down the middle, at 0.5. With this threshold, any score that's 0.5 or higher gets labeled as positive, and anything below that is negative. Super straightforward, a 50-50 split.
But what if a simple 50-50 split isn't good enough? What if the consequences of one type of mistake are way more severe than the other? This is where things get really interesting. Because as soon as you start moving that threshold, you enter a world of trade-offs. You see, you can't eliminate mistakes completely. All you can do is choose which kind of mistake you're more willing to live with.
Let's break down these two types of mistakes with an example we all know, a spam filter. A false positive is when a good, important email gets incorrectly flagged as spam. That's an incorrect alert. A false negative, on the other hand, is when a piece of spam gets through the filter and lands in your inbox. That's a misdetection.
And this is the direct result of moving that threshold. If we lower it, we make the filter more sensitive. It catches more spam. But it also raises the risk of false positives, trapping those good emails. If we raise the threshold, we make it more selective. More good emails get through, but we increase the risk of false negatives, letting more spam slip by.
And this highlights the crucial point. There is no such thing as a perfect threshold. You will always have some misclassifications. So the goal isn't perfection. The goal is to figure out which error is more costly and then do whatever you can to minimize that one.
So, with that in mind, let's see how this actually plays out in the real world, where the stakes can be much higher than just an annoying email.
Take a look at this. For something like cancer screening, the costliest mistake is obviously a false negative, missing a real case. So you'd want a lower threshold to be extra cautious, even if that means more false alarms. For spam filtering, a false positive, losing an important email, is often worse, so you'd want a higher threshold. And for fraud detection, well, just like with cancer, missing a case is the bigger disaster, so you'd set that threshold low.
This all leads us to the single most important takeaway here. The decision about where to set this threshold is not just a technical problem at all.
The source material really puts it perfectly. The ideal threshold depends on which mistake is more costly for the business. It's an economic decision, it's a strategic decision, and it's a user experience decision, all rolled into one.
So the crucial point is this. The best threshold is rarely that default 0.5. It's a deeply human decision about risk, about cost, and about what kind of errors we're willing to accept in our systems.
And understanding this trade-off, making these critical decisions, that's a huge part of a field known as AI product management. It's where technology, business strategy, and user needs all come together.
So, let me leave you with a question to chew on. If you were building an AI to predict flight delays, where would you set the threshold? What's the costlier mistake? Telling someone their flight is delayed when it isn't, or telling them it's on time when it's actually delayed? The answer isn't so simple, is it?